We are going to look at finding the slope of the tangent line to a graph at a point. For this question, we have w of t equals t squared plus 5t minus 2. We are asked in part A to find w prime of a. So that means that we need to find the derivative of our function at a. So we can go back to our definition of a derivative, which we said was the limit as h approaches 0 of f of, now this time we don't have a value. We're not finding the derivative at 1 or 3 or 5. We're finding the derivative at a. So this will look like f of a plus h minus f of a all over h. So now we need to find our different pieces. So the first thing we need is f of a plus h. So that will look like a plus h quantity squared plus 5 times a plus h minus 2. Now, if we simplify that all down, we're going to need to distribute our 5, and we're going to need to FOIL a plus h squared. So that will look like a plus h times a plus h. So if we do our distribution and we do our FOIL and we put it all together, it's going to look like a squared plus 2ah plus h squared plus 5a plus 5h minus 2. So this is coming from a plus h times a plus h. So we'll have to FOIL that. A times a gives us a squared, a times h, and then h times a gives us 2ah. H times h gives us h squared. Distributing right here, 5 times a gives us 5a, 5 times h gives us 5h, and minus 2 tags along. So then the next thing that we need is f of a. And f of a means we take out the t and we put in our a's. So this will look like a squared plus 5a minus 2. So now I need to put it all together. So this becomes the limit as h approaches 0 of a squared plus 2ah plus h squared plus 5a plus 5h minus 2 minus, and then we're subtracting this whole thing. So minus, I'm going to start a second line here, a squared minus 5a plus 2. Because if we do minus and then times this whole thing, we'll have to distribute that negative the whole way through. And that will become the minus a squared right here, minus 5a, and then plus 2. All over h. Now remember, anything that does not have an h has to cancel. So a squared right here, and here's our minus a squared right here. Here we have minus 2, here we have plus 2. Is there anything else? 5a minus 5a. So everything has an h now, because in the next step, we need to have our limit. As h approaches 0, we need to pull out the h, and that will leave us with 2a plus h plus 5. See that 5h right there? All over h. Canceling our h's. Now we've eliminated our division by 0, so we can substitute our 0 in for the h right here. And if we substitute 0 in for h, we don't write the limit anymore because we're evaluating, we're putting the 0 in. So this will leave us with 2a plus 5. So this is basically the formula for the derivative, and that's what we found in part A. In part B, it is asking us to compute the slope of the tangent line to the graph at the point 212. So if we're asked to find the slope of the tangent line, that means that we need the derivative, and we need the derivative at 2. So x right here is 2, so that means that we're going to replace our a with 2. So that will look like 2 times 2 plus 5. We're finding the derivative at 2. So the derivative work, we could go all the way back and we could replace a right here with 2, and we could work this all the way back through. But we already have our a plus h. We already have basically the formula, if you will, for the derivative. So if we're finding the derivative at any particular point, then that means that we can substitute that value in. So this is going to look like 4 plus 5, which is going to give us 9. So 9 is the slope of the tangent line at this point. Now, if it asked us to write the equation, this one doesn't, but if it asked for the equation, we could use our y minus y1 equals m times x minus x1 point slope form, and we could substitute in our 2 and our 12 for the x and y, the x1 and y1, and we could substitute 9 for the slope. For part C, it's asking us to find the instantaneous rate of change of w when t is 3. Well, the instantaneous rate of change, that means the derivative as well. Instantaneous rate of change means that our h is going to 0, and this is also the derivative. So now we need the derivative when t is 3. So that means that a from our initial formula over here now becomes 3 in our formula for the derivative. So 2 times 3 is 6, plus 5, 6 plus 5 gives us 11. So now we found the instantaneous rate of change, and we have found the tangent line, and we have found essentially the formula for the derivative.